It'll probably be just the easiest way to describe it, that way I don't have to write it down. The hardest part about this problem is that extra 2. It's this 2 right here that's going to mess you up. Don't forget about this. We do have a quiz on Monday. You should have recognized that that coefficient out front is going to be 11. That 11 comes from the fact that it's a plus 2b to the 11th. This 2 comes from, let me write on this. This 2 comes from this 2 here. I'm going to reinforce something to you. Yes?
How did you get that bottom 2? I mean, like, you said that comes from where, like the 11 over 2 thingy. Where does the 2 come from?
Oh, the 2 comes from right here.
Yeah, but where does that 2 come from?
The problem.
Oh, okay, that makes sense.
Okay, yeah, that's where that 2 came from. It came from that. So this 11 comes from either here or 9 plus 2 equals 11. If you mess up, this 11 has to be here. This 11 has to be here. But let's say you're on the test or the quiz and you accidentally put a 9 down here. You will come up with the right answer.
Really?
And that is because, if you remember when we expanded binomials, they went up and down symmetrically. So because they go up and down symmetrically, realistically, whatever number you pick out of here will be the correct thing to put in here. Because if you think about this, this is just multiplication. You can always flip multiplication, and that 9 would be on the back end, and you would then put a 9 in there. So realistically, it's more correct to put this 2 here, but if you'd put this 9, you technically get the correct answer. You're just looking for it on the front end instead of the back end of the symmetrical spectrum. But in any case, you had to remember, in order to get b squared, at some point I had to do 2b squared, which gives me 11 choose 2, 2 squared. Now we know the 2 came from, and we're good. And does this make sense then? For people that just had educated guesses? No. No, he said it very audibly. Let's just take an educated guess. Educated guess, at least, right? You knew a little bit of it. All right, any questions on this? Yes?
The 2 squared, is that just from the 2b squared?
Yep, comes from the 2b squared. So I really did, it's kind of like you distribute. It's actually 2b times 2b, which gives you 4b squared. That's where that came from. The question was just for the leading coefficient, so I actually didn't even need to use this. If you just saw it was 2 squared, you could have jumped right here. I always draw it out because it makes more sense to me then. All right, what questions do we have on the homework? Yeah, Oscar.
Number 10.
Number 10. Let's make sure I have the right one up. Does number 10 have something to do with the lottery?
Yep.
Yes. All right, what are the odds in favor of winning a lottery in which you must choose 6 numbers from 1 through 49? So we need to come up with, even with odds, you still have to come up with your total possible. So I always come up with probability before I come up with my odds. So we are picking numbers 1 through 49. If I'm picking numbers 1 through 49, in order does not matter, because order doesn't matter in a lottery, I'm going to immediately think, well, I have to do some kind of combination problem. It is some kind of combination problem. And that is going to be, so let's write combination. How small is it? Pretty small. Let's make it a little bigger. All right, we are doing a combination in order to figure out how many possible ways there are to actually win. So that will just be, well, we have 42 possible numbers, and I am picking 6 of them. So it is a combination problem. 42, choose 6, which is actually going to result in 13,983,815. Well, that means the probability in this, oh, yeah.
Wait, why would you pick 42 and choose 1 through 49 numbers?
Oh, is it 49 numbers?
Yeah.
Oh, sorry. It was just me misreading it is why. Yeah. 1 through 49, because I don't have it up here. I was just kind of going off memory. It should be 49. I am picking 6 numbers, though, right?
Yes.
Okay. Woo! Phew. Well, even though I changed that number, it still results in this, because that is the answer I had written down. Oh, actually, it's 816, isn't it? 816. I should stop going off of memory. All right, 816. So my actual probability would be, I only have one chance to win. I have to pick these exact 6 numbers. I have one chance. I'm going to pick one of these guys, and hopefully I win. So my probability would be 1 over 13,983,816. If I asked for just probability, you'd be done. Unfortunately, I asked for one step further. I asked for the odds in favor. So that's my probability. This right here is my possible outcomes. Box that in. But I am looking for my odds in favor. So the odds of this happening are actually, it says for odds in favor, so you're going to put how many successes you have. So I have 1 success. Here's where odds get a little tricky. You're actually not going to put that full 13,983,816 because one of those chances is actually a win. So you are going to put 13,983,815. Because with odds, you never put your total possible outcomes anywhere. It is how many successes to how many failures. So the easy way to always do that, if you just take your successes, subtract that away from your possible outcomes. So if I said you had 6 lottery tickets, you were allowed to buy 6 of these tickets to pick numbers. This would actually be 6 over all this to 810, because you can now succeed 5 more times because you can buy 5 more tickets. Does that mostly answer your question? I think the hard part was probably coming up with the possible outcomes, right? Yeah. All right, Hannah.
Could you do number 15?
I could. So 2 cards are chosen randomly from a pack of 52 playing cards without replacement. I'm reading without replacement. That must have something to do with dependent. Then what is the probability that at least one in my head automatically tells me do the complement? If it ever says at least one, we're going to do the complement. So it says at least one of them is a picture card, Jack, Queen, or King. So instead of calculating my actual probability, I'm going to find the complement first. So that would be P, A, prime. If what I'm looking for is at least one face card, my complement is going to be no face cards. What's the probability of having no face cards? The first thing I have to calculate, we're picking 2 cards. How many cards don't have faces on them? 12 have faces on them.
40.
It'd be 40, yeah. Yeah, you okay?
Yeah.
I'm trying to do how many don't have faces. So if I'm pulling a card, what are the chances of me not getting a face card would be 40 over 52. There are 40 cards without faces. My second card, pulling my second card, would that still be 40 over 52? No, because it says there are no replacements. Will my 40 change? Yeah, because this is, I want to pull one without a face. So if I pulled one without a face and I didn't replace it, we go from 40 without faces to 39 without faces. I have to drop one of those. And we no longer have 52 cards. We now have 51 cards. This is going to equal 1560 over 2,652. I'm going to take a break right now. Not a break. A break from this problem. I want to show you how you can use your calculator to actually reduce fractions for you, so you're not dealing with these giant fractions, because almost all these fractions reduce. Some of your calculators automatically do this. Like mine does not. So let's say I have 15,000 just exact problem, 60, and I am dividing by 2652. Some of your calculators, as soon as you hit enter, will actually have a reduced fraction in it. Mine gives me a big decimal. Decimal's not going to help me. What I want to do is I want to ask my calculator, is there a better way to write this as a fraction? So what you're going to do is you're going to hit your math key. You'll find that most of the stuff that you can do with your calculator deals with this math key. So I'm going to hit that math key. And you see here, this says fraction, this says decimal. This tells your calculator to write whatever decimal is as a fraction. This one tells your calculator to write whatever fraction you have as a decimal. I want to write it as a fraction, so I'm going to hit enter. Now it's saying, take this, try to write it as a fraction. If there's no way to simplify, it's going to pump back out 1560 over 2652. But my calculator pumps back out 10 over 17. The reduced fraction is 10 over 17, which is a lot easier to work with. So this equals 10 over 17. This wasn't what I was looking for. This was the opposite of what I was looking for. This was no faces. To calculate how many have faces, which would be just PA, that would be with faces, with at least one face. At least one face. Would basically be the opposite of 10 over 17, which is going to be 7 over 17, or you could just think of it as 1 minus 10 over 17 is 7 over 17. That is my answer. Good? Question on this one? Okay. Are there any questions on this one real quick? All right, Olivia. Number 2, which part?
At least 1.
All right, that at least 1, 4. Oh, okay. Do you mind if I just take a picture of it and talk you through it? So as soon as I see at least should, right now, should signal we need to do a complement. At least 1 tells you to do a complement. So, in fact, I didn't do anything until I calculated this at least 1, 4. And to get at least 1, 4, I'm going to do the complement first. And that is no 4s. So this right here is, what's my probability of getting no 4s? So the chance of not getting a 4 on my first roll is 5 and 6. Because we have 1, 2, 3, 5, 6. There's 5 of them out of 6. The possibility of my second die not being a 4 is 5 over 6, so that's 25 over 36. So if that's my probability having no 4s, at least 1 4 must be the opposite, which would be 11 over 36.
I just didn't flip it, so.
Oh, okay. Oh, you use the 25 over 36? I gotcha. Yeah.
I just got confused where you got the 5 over 36 from. Where it's 6 and 6.
Oh, where I got this?
Is it just because like 35?
That's exactly what it is.
Okay.
Yep. Because there's 1 and 5, which means there's 5 and 1.
4 and 2.
4 and 2, 2 and 4, and then 3 and 3. There's 5 of them. So you explained it to me, actually. All right, other questions? I'll wait for people to write this one down. Jack.
Number 12.
Number 12. I'm just going to read it for now. I see people are writing stuff down. So it says, if the odds are 2 in 1 favor of Big Blue beating the Russian Grandmaster, then what is the probability that Big Blue wins? So, in favor. In favor means he's going to win twice and he's going to lose once. So the probability of him winning must be 2 over some number. Are we okay with this? All right. So in favor, let's just write this, my odds, and it's in favor where 2, 2, 1, where he's going to succeed twice, success, and he's going to fail once. Well, the question says, what is the probability that he wins? Well, probability is how many events happen. So that's 2. He's going to win twice. and it's over all of our possible outcomes. Our possible outcomes include success and failure. So on the bottom, it's actually going to be 2 plus 1, so it would be 2 over 3. All right, that's the hard part between probability and odds. Odds don't have the 3 in it. You have to realize that both of these are all possible. You have to add those together to get a probability. Other questions? Caitlin?
Number 7.
Joe has a truck, a car, a scooter. His truck has a 1/5 chance of starting. His car has a 1/4 chance of starting. And his scooter has a 50% chance. I'm going to look at that as being 1/2 because everything else is fractions. What is the probability at least one starts tomorrow morning? At least tells you we're going to do the complement. So at least tells me to do the complement. So if it says at least one car starts, my complement is going to be no car start. And the probability of no car starting is, first of all, his truck has a 1 in 5 chance of starting, so it must have a 4 over 5 chance of not starting. If his car has a 1 in 4 chance of starting, that means his car in 4 chance of starting. And finally, his scooter has a 50-50 shot of starting, so if it's got a 1/2 chance of starting, it has a 1/2 chance of not starting. When you do this full multiplication, it's going to come out to 12 over 40. Which is going to equal 3 over 10. So you have a 3 in 10 chance of nothing starting. So that means the chance of at least one starting, so that's my at least one starts, will basically be the opposite. Instead of 3 over 10, it'll be 7 over 10. Or you can think of it as being 1 minus 3 over 10, which gives you 7 over 10. So once again, at least tells me, let's do the complement. That makes sense? Especially because you weren't here. You did the homework and everything. Awesome. Other questions? Yeah. Yeah. So 13 says, what is the probability of getting at least? Once again, it says at least one head. So that means I'm going to find the complement first. If what I'm looking for is at least one head, the complement is going to be no heads or all tails, which would be all tails. Well, we're flipping 4 coins. So the first coin being a tail would be, I have a 1/2 chance of my first coin being a tail. My second coin, I have a 1/2 chance for it to be a tail. My third coin, once again, I have a 1/2 chance of it being a tail. And finally, I have a 1/2 chance of it being a tail. So the chance of them being all tails is going to be 1 over 16. So Jack, what's going to be my if my probability of all tails is going to be 1 over 16, what's my probability of at least one head then?
It'd be
15 over 16. Yep. So our probability of all heads, or P of A, would be 15 over 16. Other questions? Okay, well, if you haven't already, let's go ahead and start that homework over the weekend. All those problems are your homework. Yes, Charlie. Yes.